So this chapter, you have aldehydes, ketones, and carboxylic acids, right? So we'll do aldehydes and ketones in a combination, right? Like a lot of it is common to both. So we'll do aldehydes and ketones together, and wherever they have like their own thing going, we'll split there. But pretty much, except for the preparation methods, I think rest of it is all the same thing for both. So aldehydes, ketones, how do you define aldehydes, ketones? What functional group is this?
It's a carbonyl group. So ketones is only a carbonyl group. Aldehydes is a carbonyl group plus a hydrogen.
So this particular group, when it's at the end of the chain, ends with hydrogen, then it's an aldehyde. But when it's in the middle of the chain, surrounded by carbons on both sides, then it's a ketone. So essentially, chemically speaking, they both are the same. The only defining feature is if there's a hydrogen attached to it, becomes an aldehyde, otherwise it's a ketone. So that's why their chemical properties also like ends up being like the same in both the cases. Okay. Before we get to nomenclature, some important points about this. So this particular thing is what defines the carbonyl group is C double bond O, right?
Yes, ma'am.
Oxygen is pretty electronegative. So that means, what can you say about this bond? Like, what can you say about this particular carbon and this bond in general?
Polar.
Yes. So there'll be a slight polarity. And this polarity is what defines a lot of the chemical properties. So because this carbon has a slight positive charge, slightly electron deficient, it takes on nucleophiles, and क्योंकि double bond hai, so it takes on like a lot of the chemical reactions. One major property is nucleophilic addition reaction. Yeah, so that's what you get here. So this bond is polarized. So delta negative, delta positive hai. What is the hybridization?
sp2.
sp2 hybridization in the carbon. What else can we talk about it? sp2 hybridization मतलब geometry क्या होगा?
Trigonoplanar.
Yeah. And what about the type of bonds? Like kitne sigma bonds, kitne pi bonds?
Just in the carbonyl group or in the complex?
In the carbonyl group.
3 sigma 1 pi.
So 3 sigma, like carbon is surrounded by 3 sigma bonds. There is 1 pi bond between carbon and oxygen. Yes. The CO bond is polarized. Either you can write it here, you can write it as a point here. So this polarization is quite important. This defines a lot of the properties. And within the compound itself, you have these plus I minus I effects that comes up because of this polarization. When it comes to nomenclature, what is the, we'll start, what's the suffix given for aldehydes?
Al.
Yeah, so when it's an aliphatic chain, it is pretty straightforward. So aliphatic ke case mein ends with Al. So if I have, for example, CH3, CH, CH2, CH2, CHO. इसका नाम क्या होगा? Like all of you guys send in the chat.
Yes.
Okay, Mitali sent it. Niti also got it. Ansh Gupta. Ansh, are you there? You working this out?
I'm not getting it.
Okay. So how confident are you guys with nomenclature? You want to practice a couple or should we go to preparation after this?
I'm okay if we like skip nomenclature.
Like I'm guessing you might have already got the question bank for this, right?
Yes, we have.
And have you tried answering the questions in that?
No,
Nomenclature?
ma'am, I haven't, because right now I'm focusing on completing the syllabus till at least January. So in February, I'll solely be focusing on question banks.
Okay.
So I haven't started any.
We'll do 2-3 nomenclature because I've seen a lot of nomenclature questions for aldehydes, ketones, like with the carbonyl group, and acids like this chapter message. Ansh, are you sending your answer? क्या हो रहा है?
Ma'am, I said that I'm not getting it.
Oh, I thought you said you were writing it. Okay. तो CHO है, मतलब aldehyde है, suffix gonna be al. Prefix के लिए, what is the longest chain containing the functional group? यहाँ से start होगा anyway, because this is the corner.
4 carbon chain.
4, तो फिर prefix क्या होगा for 4 carbons?
Bute.
Bute. So butane होगा. Always like aliphatic K are derived from the alkanes only. So instead of butane, क्योंकि यहाँ पे CHO है, this becomes butanal. Then 1, 2, 3, 4. So these 4 carbons you've already put in the name. What else is left?
Oh, CH3.
CH3. So how would you indicate this in the name? So one carbon ka branch hai na. So if it's like a normal thing, it'll be methane. But because this is a branch, this will become. And if you got it, let me know got it. Otherwise, like answer the question.
I don't know.
Okay, so this will be methyl. हमेशा alkyl groups like methane एक carbon का है. Independently it is methane. But एक hydrogen को निकाल के there's an empty bond. So this becomes methyl. So if there are 2 carbon atoms, then that becomes ethyl. So alkyl ban jayega. And you need to indicate where this methyl group is. So position number 3. Yeah. So 3-methyl butanal, or you can say, to be more accurate, 3-methyl butan 1-al. वैसे aldehydes, unless there's an acid also present, they will always take the first position. Okay, so this is when it's a suffix. Similarly, agar ketone hai, so what would be the primary suffix in the case of aliphatic ketones?
ONE.
ONA. So the process, everything else will be the exact same. So we'll just do one more for practice. तो उसका नाम क्या है? Is it visible or is it like too niche?
It's niche.
Niche?
No, it is niche.
Visible to me.
So I'll put it in the next page then. Yeah. Work on this. Tali got it?
Is it correct?
Yes. So when you have an alcoholic group that is not the primary functional group, क्योंकि यहाँ पे ketone आ गया, तो इसका prefix will become hydroxy. So when that's the only functional group, you'll put it in the end, it becomes OL, but इससे भी bigger functional group is there, which takes higher priority. So then this becomes a prefix, then that's called hydroxy. Rest of the process remains the same. Ansh, yes, absolutely. There you go. Diti also got it. Yeah. So only carbon chain we see is 5 carbon atoms long. So it's pentane. Ketone group hai, second position pe 2 on, and 4th to 3/4 position pe there's hydroxy. So when you, if at all you get nomenclature related questions, you're going to get these sort of questions only, with 2 aldehyde groups and, you know, like acid plus ketone group present, that sort of a thing. Okay. Coming to aromatic aldehydes and ketones, this is the simplest aromatic aldehyde. So iska naam kya hoga? It is whatever you are thinking.
Aldehyde.
Benzaldehyde. Benzene plus aldehyde, benzaldehyde. Yeah. So, another case, suppose you have a cyclo group. You have a compound like this. So can you figure out what this one's name could be?
Do you put it in the chat?
Yeah. You can say it out loud also.
Because it's a ring, it's a hexane ring. So cyclohexanol, and so 2-hydroxycyclohexanol.
Cyclohexanol, but how are you counting this carbon? The cyclohexa refers to 6 carbon atoms in the ring. So wahan pe,
Oh, that's an addition.
so that's why these kind of cases, then this turns into cyclohexane carbaldehyde. So this will, as you said, like 2-hydroxy will remain the same. This is the same thing. But yeah, the suffix is going to change. So if there's an extra CHO, like this will apply to your aliphatic also, where the CHO is like if CHO is part of the straight chain, of course you have to count that. But if at all you have like a ketone group or if there are two aldehyde groups where one of them is like branching off, then that turns into carbaldehyde. In the case of common names, sometimes you will come across formaldehyde also. Okay. So these are like some slight modifications to the name. Straight chains pretty straightforward, that you guys are confident with. Aromatic also, you have orthoparameta. IUPAC here, so you use the position numbers. But when you have these kind of cases where you have a cyclo compound and CHO branching off of it, then this becomes carbaldehyde, cyclopentane carbaldehyde, like that. Okay. Let's do one double ke saath, an example. What if you have CH3, C double bond O, CH2, C double bond O, CH3. तो इसका नेम क्या होगा? Actually, let me modify. Like instead of two of these, if there's an aldehyde and a ketone, so how will you treat this?
Ma'am, I forgot which one gets preference. I think it's ketone, right?
Aldehydes get preference.
Oh, okay.
So preference order में aldehyde greater than ketone. So even in case of other functional groups, like alcohol will always get a higher preference over ethers. So end of the chain is always more preference than middle of the chain. Position number of the double bond O, the oxo, Nitali. So everything remains the same. This gets highest preference, so this is carbon number 1. You have 2, 3, 4. So butane 1-al is always, it's the same as what you guys did earlier. Now, ये वाला functional group, like 3 पे क्या है? So what would be the name for this double bond O? How would you name it? That is the thing. Dhriti, yes, got it. So when you have C double bond O as a substituent, when it's not a primary thing, when it's not like the aldehyde or the ketone, especially when it's not the ketone, when it's in the middle of the chain, then this will be called oxo, OXO. Just think about it. Butanal mein 1, 2, 3, 4 carbons you counted. So there's a random double bond oxygen lying here. So you indicate that by giving the name oxo. That's it. ठीक है?
Yes.
Cool. So we'll do a opposite one. So I'll give you guys a name. But how will you, like, can you draw the structure and send the picture over WhatsApp? If you can send it over Zoom, you can send it however. If you are able to write it in a straight line, you can do that also in the chat. But okay.
Structure of this.
I'll give you the name. I haven't given it yet. So this is how some common names are written. Okay. Alpha methoxy propionylaldehyde. So IUPAC होता तो वो propanal होता है, but this is basically a common name. So IUPAC होता तो the position number is what is indicated, but because it's common, you use like alpha, beta, such terms. The alpha carbon, beta carbon. Yeah.
Can I put it in the chat box? Like, can I put it in a bracket and then put it in the chat box?
Whichever is easiest for you, so you can figure out. Either click a picture or you can put it in the chat box. Oh yeah, you got it, Mitali. Correct. So methyl नहीं है, methoxy है धृति. So अगर methoxy है तो what will the branch look like?
It'll be OCH3.
Ansh, what about you? What's going on? Working it out? Ansh also sent. Okay. Ansh, propionylaldehyde है. अगर prop होता तो how many carbons are there in the chain?
Three.
So that is the main.
I get confused between prop and pent.
Pent, like, okay, that you should not be confused. Pent, you come across pentagon, like 5 sides. Penta is always 5. So prop is 3. So 1, 2, 3. Then edge में C double bond O, H होगा aldehyde है. Alpha carbon पे you put the branch here. Another tiny mistake is methoxy is OCH3. तो यहाँ पे double bond नहीं होगा because oxygen का valency 2 है. So one bond is already attached to the CH3, इसलिए ये methoxy हो गया. So over here attached to this carbon, it only takes one bond. So whatever remaining valencies are there, they're all fulfilled by hydrogen. So this would be the structure. Okay. Okay. So Anj, a little more practice. I'd sent a website. Do you guys remember? Like nomenclature practice करने के लिए. It gives you a quiz of 10 questions each time. You can set what all functional groups and difficulty level and all. I'll ping it again. So this time you can just choose exclusively aldehydes, ketones and practice. So this teaching में ज़्यादा नहीं है. Like again, it's kind of like math. The more types of questions you do, the more compounds you do, the better you'll get at this. Okay. So now coming to preparation. So preparation method, the first one is oxidation. You have studied this reaction pehle. So kisko oxidize karne pe you're going to get aldehydes ketones?
Alcohol.
There you go. And what is the oxidizing agent that you use?
Weak oxidizing agent, because a strong oxidizing agent is used, then it will directly be converted to carboxylic acid, which we don't want.
Correct.
So
if I take
KMNO4.
KMNO4, what are the conditions you need to apply so that it can go to an acid? Stop set.
I
Now
don't
you've
know.
studied chemical kinetics also. So if you don't want a reaction to go fast, तो temperature के साथ क्या करना चाहिए?
You can add like the opposite thingy of the catalyst. What's the name of
That's
it?
making it quite complicated. Like think of the first thing. Temperature, should I take hot KMNO4 or cold KMNO4?
Cold KMNO4.
And should I take
Temperature will
concentrated or diluted?
dilute.
Dilute. So cold dilute, and in terms of catalyst, alkaline KMNO4 will result in aldehydes and ketones. Iska opposite, if I take hot concentrated acidified KMNO4 like acid medium mein, that's going to oxidize it straight away to acids, carboxylic acids. So KMNO4, K2Cr2O7, these are like the common oxidizing agents. Take it in such a way that you can control the reaction. You take cold dilute alkaline conditions mein these oxidizing agents. Okay, next thing is, if I want to get aldehydes, what sort of alcohol should I take?
Now for aldehydes, when we did the previous chapter, formaldehyde was given by formaldehyde gave primary alcohol. So
Right.
primary and secondary alcohols will give us aldehyde, and tertiary alcohols will give us ketone.
Secondary, will it give you aldehyde?
No, then secondary will give us ketone.
So think about it logically, no? So primary alcohols, matlab, they are there at the end of the chain. यहाँ पे only one carbon का attachment है. So when you're oxidizing it, you're basically removing the hydrogen and converting this into a double bond. So end of the chain matlab aldehyde ban jayega. Secondary alcohols, they're there in the middle of the chain. So connected to two other carbon atoms. So isko oxidize karne mein, you're removing the hydrogen, converting this to a double bond. So what you end up with is a ketone, because this carbon is surrounded by two other carbon atoms. Okay. So tertiary does not undergo that easily. Like tertiary alcohols ka oxidation is very, very difficult. You need to take extremely strong oxidizing agent, and that breaks the carbon-carbon bond. So tertiary hai, so it becomes two smaller molecules, and you end up getting ketones or aldehyde depending on the structure. Okay, so primary alcohols give aldehydes, secondary alcohol gives ketones. So mainly if you want aldehydes, take something that's in the corner, because you want your aldehyde ke liye C double bond OH oxygen to be in the corner. Ketones ke liye take something that's in the middle, because so that's why you end up taking secondary alcohols. Okay. Riti, Ansh, let me know when you guys have finished noting. We'll go to the next method.
1 second.
And logic समझ में आया क्या? Like, is it now easy to remember, easy to figure out?
Yes, ma'am. So, ma'am, preparation for aldehydes and ketones, both of them are on the same lines.
Yeah.
Like,
There are some reagents that vary. Like when they vary, I'll take each of them separately. For now, first we'll start off with all the common things, common methods, common ground. Because they're very similar, like in their preparation property, like in their structure, they're very similar. They have a lot of things common. So it's easy to study them together instead of doing it.
Done.
Okay. Ansh? Yeah. Okay. All right. So oxidizing agents like KMNO4, K2Cr2O7, they are more laboratory oxidizing agents, which, you can take some permanganate, you can prepare it, whether you want it acidified, alkaline, whatever the case is. But on an industrial scale, this will not work. So industrial scale, maybe you use the same principles, but different process or reagent. So in that case, we don't like it is basically oxidation, but we basically call it dehydrogenation of alcohols. Hydrogenation matlab you're adding hydrogen. Dehydrogenation matlab you're taking away the hydrogen. So this is an industrial preparation method. So this is like you basically use volatile alcohols for this. From volatile alcohols. So again, same thing. So ROH, the reagent that you use in this case is you make it pass through silver or copper tubes. So the silver, copper, whatever is there, it takes away the hydrogen and gives you the aldehyde or ketone. This is also pretty fairly obvious. Aldehyde you get from primary alcohols, and ketones you get from secondary alcohols. Because essentially what is happening bond wise, like to the molecule, is the same thing. So you have carbon and then oxygen here. Depending on what it is attached to, you're removing the hydrogen from here and here. So if you have another hydrogen attached, you end up getting an alcohol. If you have carbon attached on both sides, you end up getting a ketone. So the logic or what's happening back end may, that's the same thing, just that the scale is different. You can't use so much permanganate and all that in at an industrial level. It's easier if you have a gas, you can like direct that gas, make it pass through heated copper tubes, silver tubes, or tubes covered with copper silver, and then you end up doing the reaction based on that. There's another reaction again. This also you guys are, I don't know if I can say you're familiar with, but you had studied this in 11th standard from alkenes. So alkenes को aldehydes ketones बनाने के लिए, do you remember any specific reaction?
Need we do ozonolysis?
Ozonolysis, yes. Again, if you remember ozonolysis, basically you have R double bond R, or let's make it more accurate, instead of R we say C double bond C, and they're attached to whatever different things. Ozonolysis ke baad, you end up like the double bond is replaced by double bond oxygen. So rest of the things remains the same. So if you want one specific aldehyde or one specific ketone, you need to take that suitable alkene so that you get the same product on both sides. Okay, if you don't mind a mixture of it, then you take any random alkene. But this is essentially what's happening. I'll just write this again, rewrite it, showing the entire mechanism. So you have C double bond C. What happens in ozonolysis is the focus on the double bond. So first step is adding ozone. You get like a house kind of a structure. These two remain the same, but यहाँ पे एक oxygen है, the second and third oxygens get added like this. Now this is kind of unstable. In the presence of zinc, the hydrolysis happens, and then this breaks to give. So basically, if you look at the first product, end product, like first reactant to the end product, यहाँ पे जो double bond है, that breaks, and instead of double bond being connected to each other, there's like oxygen on each side. So that's what happens. So now using this logic, if you want to prepare a specific aldehyde or a ketone, you can figure it out. So here's a practice question. Suppose I want to prepare acetaldehyde. So to prepare acetaldehyde, what is the alkene should I take?
Acetaldehyde is CH3CHO, right?
Yeah. Wherever you see ACE acid, like acetate, acetal, it's 2 carbon atoms long. So acetaldehyde is CH3CHO. So form is for 1 carbon. So formic acid, formaldehyde, that way. Acid, ACE, acetate, acetaldehyde is like 2 carbon atoms. So you have acetic acid, acetaldehyde, acetylene.
Ma'am, are we assuming that both the products are acetaldehyde?
I want to prepare acetaldehyde only.
Okay. So both like, okay.
Yeah. Like I don't want any other product in the mixture. I want only acetaldehyde.
Okay. No.
Nice. Yes, Mitali got it. Okay, Dhriti, Ansh, working it out.
Yes, ma'am.
Okay. So work backwards from here. I want CH3CHO. So put that in the product side. So यहाँ पे CH3 चाहिए, CHO. So this is the product I want, and I want only this. तो दोनों compounds यही होना चाहिए. तो reverse engineer. तो यहाँ पे मेरा alkene क्या होना चाहिए? So remove the oxygen, figure out what you get. धृति चेक अगेन, कितने कार्बन एटम्स है यहाँ पे? बीच में कार्बन नहीं होगा, द डबल बॉन्ड कनेक्ट विथ ईच अदर डायरेक्टली. So what I'm doing here is C double bond C, उसको break करके I'm just putting an oxygen here. So if I go from here to here, basically take away the oxygen and directly join them with a double bond यहाँ पे. So Dhriti, try again. And Ansh, let me know if you gotten it, you're typing the answer or क्या हो रहा है.
Ma'am,
Yeah.
you have to answer the question in the black ink, right?
Dhriti and Anj, both of you got the same thing. क्यों? कैसे? So how did you guys get 5 carbon atoms? Like, can you tell me like how you worked it out? Either Dhriti or Ansh, one of you.
Miss, no, I don't. I mean, my answer is definitely wrong. I'm working it out just to.
You're still working, okay. Ansh, like how did you come across C5H10? Can you explain? Ansh? Oh no, कुछ हो गया. Just restart your mic once, Ansh. हाँ, Dhriti, now you got it. पहले क्या हुआ? Like, why did you get pent tween पहले? Dhriti?
Ma'am, I just got a lot confused, and then you explained Upper, so.
Acha. Oh, so that was like a random guess or something. Okay. No, I want to know like why you got confused. Uske basis pe I cannot like make that mistake again. So basically this is the case. Acetaldehyde is CH3CHO. Write down the structure so that you know where that double bond is. So this is the structure, CH3 C double bond OH. And दूसरा side भी यही होना चाहिए because this is the only product I want. उसके बाद wherever the oxygen is, take away the oxygen and join the remaining carbons here. So essentially I'll get C double bond C. इस तरफ I have a CH3 and H. इस तरफ I have a CH3 and an H. And see what you got. 4 carbon atoms. बीच में यहाँ पे double bond है. So that's 2-butene. Okay. Clarified now, Ansh? And Shantanu, what
Miss, do
happened?
you mind if I go get my breakfast? I'll be back in 2 minutes.
Yeah. Right. Ansh, do you want to like rejoin by the time Riti goes and comes back? Okay. Shantanu, what happened? Why so late?
Ma'am, I forgot we had class in the morning. So
Oh God. Oh man, you need to like set your alarms and reminders based on that.
I woke up at 6 by accident and then I slept after that.
Okay. ठीक है, like anyway, like catch the recording of the first hour. Okay. All right. So again, just to summarize preparation methods, agar alcohol say if you're starting, you just replace the OH with double bond O. That's what is happening. Hydrogen is being eliminated, and then just like how alkenes ke case mein you remove the hydrogen and that turns into a double bond, same thing that happens here also. Ozonolysis mein, wherever there's a double bond between the carbons, that breaks and then you have double bond oxygen. And there's one more reaction. So once Dhriti and Ansh join in, we'll resume. Okay. So you want you guys also like if you wanna get something to eat, drink, just take a quick break.
Okay, ma'am. Thank you.
Okay. Ansh, clear?
Yes, ma'am.
Okay. All right. So alkenes say agar if you want aldehydes ketones, we've got ozonolysis. Another one, fourth reaction is hydration of alkynes. Okay. So again, very self-explanatory. You take an alkyne. So alkyne matlab you have a triple bond. Hydrate it. Hydrate matlab what are you adding?
H2O.
Yeah.
Water.
Water. So water. So basically addition is always, hydrating always in acidic medium because you want that H plus to kickstart the reaction. So in presence of H2SO4. It's like a regular addition reaction only, Markovnikov, anti-Markovnikov, whatever you have, OH is added. So this particular configuration, so this is called enol. Enol because you have a double bond for en, OH for all. So whenever you have this sort of a configuration, right, there's going to be a kind of resonance that's happening here because you have a double bond, for single bond, for oxygen pe you have the lone pair of electrons, right? So double bond, single bond, lone pair matlab conjugated system, matlab resonance ho jayega. So during this resonance, this will rearrange itself to form a ketone kind of a group. This will become single bond O. The hydrogen will migrate over here. And the rest of it remains the same. Okay. So this sort of rearrangement is called keto-enol tautomerization. So tautomerization is basically like rearranging. Both of them are isomers, like the structure is the same, everything is the same. Just that enol configuration turned into a ketone configuration. Yeah. One drawback with this is drawback nahi. Again, a criteria for this, again, if you want a specific product, no, again, you have to take the reactant based on what product you want. Because triple bond may you're getting like one of the double bond O getting added. So if you want a ketone, you can take any alkyne depending on the number of carbons and everything. But if you want aldehyde, you need to take the alkyne that is there in the corner specifically, because aldehyde के लिए यहाँ पे hydrogen चाहिए ना, so always one alkyne लेना पड़ेगा, like one pentyne, one hexyne, that way. So if you want to get an aldehyde, for aldehyde, the triple bond should be in the corner, and for ketones, the triple bond should be in the middle of the chain. Okay. So we'll do a couple of example questions based on this logic. Question number 1 would be, if I take 2-butene. 2-butene on adding, like on hydration, what is the product? So give me the product for this. And question 2 is, to get acetone, what alkyne is required in this reaction?
Ma'am, just a second. So we need to solve this and then we need to send the answer, correct? So the first one, final answer, right? You don't want the intermediate product.
No. So give me the aldehyde or ketone that you get from this. And in this case, what alkyne? So I'm expecting an alkyne to be the final answer for this. So we 10:19 ho raha hai na? Take a couple of minutes. I'll start discussing it at around 10:22. So this is also here. You can just.
Ma'am, acetone is CH3, C double bond O CH3, right?
Yes. Dhriti, first one MCQ नहीं है. I was asking दोनों में से, like, give me the product का final answer, not whether it's aldehyde or ketone, which aldehyde or ketone is going to be formed. Like, I meant not the enol, but the final product. Okay. So Mitali and Riti have gotten the first answer. सही है. Mitali, okay. Nice. Mitali got the second one also. Good. So Dhriti, Ansh, Shantanu. First one you should be able to do क्योंकि direct है वो.
Miss, I'm doing the second one. 1 second.
हाँ. Nice. Okay. So Dhriti and Mitali have gotten the second one also. Ansh, first one you got it. That is correct. Okay. Shantanu, क्या हो रहा है? Working it out. So if, like, I know you just joined in. So if you're, if something is not clear, if you're trying to figure it out, क्या कैसे, let me know. We'll do it together. Yeah, Shantanu?
I don't get it.
Not getting? Okay. So first one, the rest of you have done it. So I'll just discuss that. Okay. So 2-butene चाहिए. So 2-butene का structure क्या है? How many carbon atoms, Shantanu? Second one, Ansh, reactant is an alkyne. So check your answer again. कौन से alkyne से मिलेगा acetone? And there is no bond breaking. You're not getting two different products. वो तो पहले answer, like पहले वाले में था. So just check.
It's 2 carbon.
Okay. Shantanu, bute मतलब कितने carbon atoms? 4. फिर butene है. Ine मतलब what is the functional group? तो ट्रिपल बॉन्ड होना चाहिए. और where is the triple bond? Where is the triple bond, Shantanu? Second one, यहाँ पे होना चाहिए. So this is our compound, like this is our reactant. So follow the same logic what you are following here. Okay. So H2O, H2SO4 add करने पे there is H and OH being added. And जहाँ पे भी OH add हुआ, that turns into a double bond. तो यहाँ पे final product कैसे दिखेगा? Where will you find the double bond in this case? Will it be on the first carbon, second, third, or fourth? So the chain remains. Second, either second or third, like wherever you count from, it's the same thing. The rest of it all remains the same. यहाँ पे extra hydrogen, this is one hydrogen being added, and the one migrated here, this is the second one added. So this becomes CH2. This remains as it is. So this is my product. फिर इसका नाम बताना चाहिए. That's 2-butanone. And now you got it. Second one, aa gaya. So the second one, to get acetone, matlab we have our final product, which is CH3, C double bond O, CH3. This is acetone. Okay, propanol. तो ये कहाँ से आएगा? इसका बिल्कुल reverse, like just take away the oxygen. So if I take away the oxygen, one of these two bonds should have a triple bond. Now it's perfectly symmetrical on both sides, so it doesn't matter where I have it. So wahan se I get CH3, C double bond, CH. So this is going to be my original reactant. What alkyne is taken? So propyne is taken. Okay? Cool. All right. So that's preparation of aldehydes and ketones. So that's like preparation of aldehydes and ketones together. Matlab ek hi method se it is dependent on the reactant whether I'm getting an aldehyde or a ketone. Okay. So like in the first case, alcohol ke oxidation ke case mein, depending on whether I'm taking primary or secondary, I'm getting either aldehyde or ketone. Ozonolysis also, it's completely dependent on yahan pe what is bonded. Same in the case of alkynes also, right? So now we look at some specific preparation of aldehydes alone. So these methods of preparation, like if I take a specific class of compounds, depending on the reagent that I take, I am always going to get aldehyde. If I change the reagent, I will get a ketone. So now we'll tackle aldehydes first. Preparation of aldehydes alone. Again, before we get on to this, this chapter is filled with a whole lot of named reactions. So again, like exam wise, if you compare, named reactions are pretty, it's like examiner's favorite type of thing. So that's something that you guys will need to learn and remember in this chapter. A lot of important reactions that way. The first one is preparation from acyl chloride. What I'll do is, after taking all of these, right, I will we'll make a summary of all the named reactions so that it's all there in like one place. It's easy to figure out which name is which reaction instead of it being lost in all of the reactions. So acyl chloride, this reaction is called Rosenmund reaction. So acyl chloride kya hota hai? Okay. Do you know, remember the structure of acyl chloride? What is this?
COCl.
Yes, COCl, C double bond OCl. Attached to whatever, okay? Now, this on hydrogenation in the presence of palladium and BaSO4. So hydrogen gets added to it and Cl gets eliminated. So I end up getting R, C double bond O H. Okay, mechanism and all gets it's a little complicated, but essentially this is the reaction. Actually, just let me go through the reactions of ketones also. Do you guys want to do aldehydes properly separately than ketones, or from the same reactant what will get me aldehyde, what will get me ketone, like parallelly? Do you want to do a comparison sort of a thing?
No, miss. Comparison, I get confused.
Okay, so we'll do it.
Can we do them separately?
Okay. क्योंकि reactant same ही है, because we have acyl chloride, we have nitriles, and then we have the aromatics. So ठीक है.
Ma'am, the textbook is given in the same format that you've explained.
Okay.
So I'm fine with either. I mean, the other one will save us time and we might finish a lot more things and doing it separately, but then that's okay.
But no, like priority is it doesn't, saving time doesn't matter if if it was all for nothing. So that's the priority here. What will you guys prefer? Okay, so this is acyl chloride. Then we have nitriles. Just a moment, guys. आंटी अभी रहने दीजिए ना.
हाँ ठीक है कट कर देती हूँ
हाँ.
दरवाजा बंद कर दो बस
Okay, next we have nitriles. So nitriles के case में, okay, we have a couple of reactions. Okay, so first, if we take a nitrile, do you guys remember the structure of a nitrile?
Isn't nitrile CN?
Yes. So C triple bond N. This is a nitrile. If the reagent you use is stannous chloride in the presence of HCl, so this first turns into an imine. Imine is basically an amine except with a double bond, like alkane, amine, alkene, imine. So associate the sound E with like basically double bond. So this is called an imine. So this on acidic hydrolysis, H3O plus, you get RCHO. So this particular reaction, like when you use stannous chloride plus HCl, this is called Stephen reaction. Okay. Then you have another reagent also you can use in the same, you have nitrile, R, C triple bond N. So this particular reagent is called Dibal H. Okay. The process is the same again, like again, whether you use stannous chloride or Dibal H, the source or the main thing is that there is hydrogen being added across the nitrile. So essentially the intermediates and all, whatever you get will be the same thing. Again, you'll end up with an imine, which on acidic hydrolysis will give you RCHO. So Dibal H, the full form for this is diisobutyl aluminium hydride. Okay, it's a very self-explanatory name. So diisobutyl aluminium Al hydride is H. So iska formula hai. So you have aluminium hydride and two isobutyl groups attached to it. So isobutyl shortened to IBU taken twice. This is the formula. If you want to expand the structure, same thing, like isobutyl is 4 carbon atoms, iso here, so this will be here. So this part is basically connected to the aluminium hydride part. Okay. What else do we have? Yeah. So another thing, if you're using dibalH, you can either take a nitrile or you can achieve the same thing with an ester also. Okay, ester I'll do it separately next time. Let me know when you guys have noted this down. Again, all of this is purely just information. Rosenmund reaction is hydrogenation. You can think of it as hydrogenation. Acyl chloride, hydrogen substitutes, you get aldehyde. Stephen reaction, you use stannous chloride plus HCl. This is going to give up a hydrogen, converting your nitrile into an amine, which on hydrolysis turns into CHO. Using dibalH also is the same mechanism. So dibalH aluminium hydride gives up the hydrogen here, reduces it into an amine, which on hydrolysis gives you this thing. Okay. Ansh, Shantanu, let me know. Shantanu got disconnected again. Yeah. Okay. So let me know when you guys, Dhriti is done, Mitali is done. Ansh, tell me when you're done noting this, then we'll do the reaction with ester. Quickly go close the door in the meantime. All right, Ansh, are you done? Should we continue? Yeah, okay. So dibalH, you can use it for with esters as well. So ester, do you remember structure क्या है?
C double bond O and O.
Okay, and then this is connected to another R dash. Okay, so again, same thing, use dibalH. In the case of ester, and then again use hydrolysis होने पे, you get R C double bond O H. Okay. So essentially the part that is attached to C double bond O gets converted into the aldehyde. So this is indirectly in a way reduction of an acid derivative. Like even in the case of acyl chloride, वही हुआ. यहाँ पे acyl chloride is a derivative of acid, like COH converted to COCl. So in place of Cl, you have a hydrogen there. Here also the same thing is happening. Ester is acid derivative, like this whole part is coming from the alcohol. So the alcohol se jo bhi aa raha hai, that's getting cut off and this is getting converted to an aldehyde. Yeah. So that's something you can take note of. So when you're predicting the products and all, don't be confused whether iske saath hoga ya iske saath hoga. So whatever is attached to C double bond O, that will be the part of the aldehyde. What else do we have? Nitriles, esters ho gaya. Huh. From aromatic aldehydes. So how do you get aromatic aldehydes from hydrocarbons? So aromatic matlab start off with benzene. Can you directly convert benzene into benzaldehyde?
I think so.
How would you do that? How would you introduce? So see, benzaldehyde is you have a benzene ring and you have a CHO, right? अगर यहाँ पे एक carbon है already, then you can oxidize it and then convert it into an aldehyde. So in order to do that,
You may need to introduce a carbon first.
yes. So either you can start off with toluene directly, or if you're starting off with benzene, convert it into a toluene. Any of you guys remember how to introduce methyl group to benzene? Electrophilic substitution hoga. There's a whole, so you need to substitute CH3 over here. Do you guys not
What
remember
would be the reagent?
CH3Cl in the presence of AlCl3? Do you remember? Friedel
Alkylation.
alkylation reaction, because you're introducing an alkyl group here. So either do this first or you can start off directly with toluene. Then isko oxidize karna hai. So introduce OH over here, CH2OH, convert it into an alcohol. Then convert, like isko basically oxidize karna hai. So convert it into an alcohol, then you can directly convert it into an aldehyde. Or you have ways to directly oxidize it also. There's some other reagents for it. So this is what is used in the industry, okay? So theoretically, this is possible. Industrially, like in real life, like this is what is used. So note down this reaction. So start off with toluene. This in the presence of CrO2Cl2 in carbon disulfide solution. So this particular reagent is called chromyl chloride. You get an intermediate here. So an intermediate associated with this directly. So you get CH. So two of the hydrogens are substituted with this whole thing. Like these two carbon atoms are, you get CrOHCl2 taken twice. And this on acidic hydrolysis gives you benzene. Okay. So when you follow this method using chromyl chloride, this particular reaction is called Etard reaction. So when you use chromyl chloride, you get a chromium based intermediate, which on acidic hydrolysis gives you benzaldehyde. You have another oxidizing agent also you can use. Once you're all done noting it, then we'll go to the next part.
Done, ma'am.
Done, ma'am.
Ansh? So again, same thing, you start off with toluene. This time the oxidizing agent is chromic acid. So CrO3, CH3, CO taken twice O. Heated 270, so 270 to 283 Kelvin. So this particular agent, this is chromic acid. So chromic oxide, sorry. So यहाँ पे you get, so this whole part gets substituted over here. So again, CH, CH3, CO. So यहाँ पे O, CO, CH3 taken twice, and this on acidic hydrolysis gives you benzaldehyde.
So only when we use chromic chloride, only then it's called Etard's reaction, right? If we use
Yeah.
chromic oxide, it's not. It's just
Okay.
another reaction.
So this is benzaldehyde diacetate. Again, see why इसका structure है, you have benzene, then you have CH, then this is attached to O, C double bond O, CH3, and यहाँ पे भी you have another O, C double bond O, CH3. So you can see there are two acetate groups attached, where otherwise it could be like a single oxygen. So it's like benzaldehyde में oxygen निकाल के you have two acetate groups. So this is called benzaldehyde diacetate. Okay. So when you use chromic oxide, this is chromic oxide plus acid anhydride, right? You can see that. So the acetate groups gets attached to the toluene, and then on acidic hydrolysis, this gets detached, that gets converted to benzaldehyde. When you use chromyl chloride, you get a chromium based intermediate, which on acidic hydrolysis gives you benzaldehyde. Okay, so these are all preparations of aldehydes specifically. Just to revise, recap, if you use acyl chloride, it's called Rosenmund reaction. Basically, hydrogenation, you are substituting the chlorine with hydrogen, basically. Nitriles and esters ke case mein, again, same logic where you're reducing this to produce imines, and on hydrolysis, the double bond N gets substituted with double bond O. So imines get converted to aldehydes. In this case, yeah, so finally you get this. For aromatic specifically, lots of ways of going through it. One direct approach you can do is convert this to toluene, convert it to alcohol, then oxidize it to get aldehyde. Preferred methods of preparation is by using chromyl chloride, in which case called Etard reaction, or you can use chromic oxide with acid anhydride. So when you get this intermediate, you get benzaldehyde. Yeah. Now,
So now we move on to ketones, right?
ketones, yes. Oh, there's a couple more. Oh, Gatterman Coke, did not realize. So there's a couple more aldehyde ke reactions here. And Another way to prepare is like this is oxidation of toluene. Another way for aromatic aldehydes, you have side chain chlorination and hydrolysis. Again, you have a side chain, add chlorine to it, and then do hydrolysis. So instead of oxidizing it to alcohol, we are basically doing this. So start off with toluene, then chlorinate it. You can use this confidently because benzene may this particular like free radical substitution will not happen because of resonance and all that. So you can be confident that this chlorine will be substituted on the CH3 only. Let it get substituted to CHCl2. Then on hydrolysis, you get benzaldehyde. So this is called benzyl chloride. Benzyl chloride would be CH2Cl. Benzyl chloride means यहाँ पे CH है because it looks like a derivative of benzaldehyde. Okay. And you have one more named reaction. So this is Gattermann-Koch reaction. So basically you take benzene. So you're directly like brute forcing CHO into it by using carbon monoxide and HCl in the presence of anhydrous AlCl3 or CuCl. Basically your Lewis acid चाहिए यहाँ से.
Miss, 1 second, can you go to the previous slide?
हाँ.
Yes, ma'am.
You get CHO. So that's it for preparation of aldehydes. Then we look at preparation of ketones alone. Okay. Let me know when you guys are ready.
Shouldn't this be the fourth reaction because we did a side chain chlorination plus hydrolysis right before this?
That's the second one. The chromyl chloride, chromic acid, the reagents are different, but essentially both of them are oxidation of toluene.
Oh, so I've like taken up, I've taken up this too. Okay.
This was benzene. Okay, I don't know what happened here. All right. Dhriti, Shantanu, let me know when you're ready. So we'll follow the same pattern. Aldehydes के case में भी, if I take acyl chloride, क्या होगा? Here also we'll start off with acyl chloride. So aldehydes के case में, we took acyl chloride and we used a reagent to substitute the Cl with H. इसलिए हमने stannous chloride plus HCl लिया, dibal H लिया, like things like that. In this case, ketone चाहिए, तो we need to substitute this with R, like another alkyl group. So whenever you want to introduce alkyl group, what reagent do you use?
When we like use like a Woods reaction, we add like.
So वो तो direct alkyl halide से आ गया. If I use alkyl halide, it won't work because यहाँ पे anyway alkyl group है, C double bond हो है. It's going to be slightly difficult. What other reagents have you used पहले to increase the number of carbon atoms, for example? So for the preparation of ketones, because you want to increase it by R, you start off with Grignard.
Oh.
So R MgX, Grignard reagent. Instead of using Grignard reagent directly, you treat it a little bit to make it like properly reactive. You prepare Grignard reagent and add a little bit of cadmium chloride to it, CdCl2. Then you get a cadmium based reactant. Take 2 of this. You get CdR2 plus 2 MgXCl. तो अगर यहाँ पे Cl ही लिया तो you get MgCl2 basically. और कोई halogen लिया तो you get that compound product. So now this CdR2 make it react with acyl chloride, they will get effectively reacted.
So ma'am, it's R2, right? So now it will become R, C double bond O, R twice.
R dash ले लो. R twice यहाँ पे 2 bond नहीं form कर सकते ना. So this will be again like twice, 2 of R dash. Then you get 2 double, or since you're taking double of this, you get 2 ketones and you get your CdCl2 back. So this particular product that you get, that's called dialkyl cadmium. You can think of it as a catalyst because end of the reaction, you're regenerating your CdCl2 here. Okay. So aldehyde ke liye is pretty straightforward. You just need a hydrogen, find sources of hydrogen, put it here. Acyl ketones ke liye, you want to add more carbon chain to it. Alkyl group add karna padega. So your source of alkyl group is gonna be Grignard reagent. Go back and check other reactions with Grignard reagent. So whenever you had to like extend a chain or something like that, Grignard reagent is pretty effective. Okay. Next, aldehyde ke liye we saw nitrile. Either B, we look at reaction with nitrile. So nitriles again are C triple bond N. Here also treat it with Grignard reagent because you want to introduce an alkyl group. So R dash MgX in the presence of ether. So you get वहाँ पे imines, you got an imine because hydrogen was added here. In this case, R dash is going to be added here. So you get C double bond N MgBr or MgX, whatever you've taken here. And R dash is added here. And this on acidic hydrolysis again.
Miss, one second, can you go to the previous page?
Huh. ठीक है. Finish noting and then we'll continue. So let me know
Done, ma'am.
immediately, like whenever.
Sorry, ma'am.
फिर interruption हो जाएगा ना, like the flow will break. Now we can like start properly once you're also done noting. So nitrile do Grignard reagent in the presence of ether. It's a direct addition again. So when you had taken dibal H, SnCl2HCl like sources of hydrogen, वहाँ पे hydrogen were added. But since you want to add alkyl group, we are taking Grignard reagent. Again, same thing is happening. So R dash is being added over here and MgBr is adding over here. And this is the intermediate that you get. You don't want all of these complications. Acidic hydrolysis, you end up getting a ketone. And yeah, the remaining just escapes off. Like this becomes your byproduct. So every time you do acidic hydrolysis, like this becomes a common theme in the reactions of acids also. Preparation of acids also, you try to create like an acyl chloride or an ester or an anhydride, and then try to do hydrolysis, like acidic hydrolysis. And whatever substituent you have, that gets substituted with OH from the acidic hydrolysis from the water. And finally, for aromatic ketones. So aromatic ketones ke liye, you get it from benzene or substituted benzene, like toluene basically. So you start off with benzene. So यहाँ पे, in order to get ketone, like basically what you want to end up with is something like this. And then R dash here, right? So this would be an aromatic ketone. So we want a source to introduce this C double bond O.
Ma'am, electrophilic substitution, acylation.
Acylation, basically, yes. So यहाँ पे either another phenyl group or R, depending on what you want substituted over here. So if you want another benzene ring over here, then you take a phenyl group here. If you want like a straight chain, you take that particular acyl chloride. Presence of anhydrous AlCl3. You get that. So AR or R, depending on what you've taken over here. Straightforward. That's it. It's 11. Good. We have one more hour. Addition is all right. Oh. We have time only for doing the nucleophilic addition reactions today. Do you want to get on to properties now, or try to answer some questions based on preparation methods, these reactions?
No, I'm fine with either.
Dhriti and Shantanu.
Miss, I'm okay with anything.
Anything is fine. Okay. Are you still feeling fresh? Like start taking on the properties? Okay. Okay.
Okay, ma'am. Miss, can we do it like after 5 minutes?
Okay. We have only like 50 minutes, less than an hour of the class left. Okay, Ansh and Shantanu, let me know when you guys are also ready. I've not heard from you.
Yes, ma'am.
Ma'am, okay. 2-3 minutes, like 11-10 को start करते हैं, ठीक है? Come on. Okay, physical properties. You guys only quickly tell me. The first one, okay, like physical state, the smaller ones are gases. So methanol, HCHO, formaldehyde is a gas. Ethanol, CH3CHO, is an extremely volatile liquid. So that's like extremely low boiling point. And this is all at room temperature. Even the first, which one is the first ketone? Do we have methanone and ethanone existing?
No, ma'am, we don't, because a minimum of 3 carbons are required for formation of ketone.
Yes. So ketone center में होना चाहिए means like you need at least 1 carbon atom on each side. So this is the smallest ketone. Acetone is also an extremely volatile liquid at room temperature. You all have seen acetone actually. I know.
Nail
Anshu-
polish.
Yes. Shantanu, I'm not sure if you have got sisters or if your mom uses nail polish. Yeah. So this is basically your nail polish remover. So if you've handled it or used it, if you put a little bit on your skin, it feels cold, right? And it
Yes.
evaporates pretty quickly because that coldness is because of the evaporation. And it is capable of doing that because it's so volatile, extremely low boiling point, boils up on your skin. Okay. So these are like your phases, and then the higher ones, as the mass increases, slowly you get a lot of liquids and then solids. Next, so basically the result of this, we can say boiling point. Let me put in a different color. So boiling point increases as the number of carbon atoms increases. Same with melting point. Another comparison of boiling point, like aldehydes and ketones have got the oxygen, right? Alcohols also have oxygen. So when they have comparable mass, like if I'm counting a 2 carbon aldehyde versus 2 carbon atom alcohol, what can you say about the boiling point? Which one will have a higher boiling point between alcohols and aldehydes?
Ma'am, which one will have a
Higher boiling point?
aldehydes or ketones?
Aldehydes or alcohols with the same number of carbon atoms.
Alcohols.
The reason?
H bonding.
There you go. Correct. So, but aldehydes, ketones, okay, first, this is the order, okay? So you have alcohols will have a greater one compared to aldehydes, ketones. Aldehydes, ketones have comparable things. Okay. Very minute differences between aldehydes, ketones, pretty much comparable. They will have greater than ethers, and this is definitely more than alkanes. Okay. Now, what is the reason for this? You said hydrogen bonding, yes. But aldehydes ketones also have C double bond O. Why is there no hydrogen bonding in this case? So this bond is also polar. So alcohols is ROH.
Steric hindrance.
Hmm?
Steric hindrance.
Not really. What is the fundamental difference between the structure of alcohol versus structure of aldehyde?
There's a presence of H atom.
Where? Because there's H everywhere.
Oh, there is no H attached to the oxygen atom.
Correct. So the polarity between these two is a lot more than the polarity that would be present in these two. So यहाँ पे you have hydrogen bonding. यहाँ पे hydrogen bonding is not there. You only have dipole interactions. If you remember, like when we were doing chemical bonding, like states of matter, talking about these different interactions, hydrogen bonding is basically these dipole-dipole forces on steroids. It's like 10 times stronger than dipole interactions. So that is the fundamental difference why alcohols still have a lot more compared to aldehydes ketones. Even though both have polarity, the hydrogen is directly attached to this electronegative oxygen. So iska polarity is a lot more than iska polarity. Like this is a lot stronger than this polarity. Okay. So यहाँ पे हाइड्रोजन बॉन्डिंग है, यहाँ पे डाइपोल इंटरेक्शंस है which are relatively weaker than hydrogen bonding. Ethers though, again the oxygen is attached to carbons on both sides, so it's a lot lesser, but at least the presence of oxygen is causing their melting point, boiling point to be higher than pure alkanes which don't have oxygen at all. So that's the order in this situation. Okay. This is okay. We've talked about melting point, boiling point. Next, let's look at the solubility. What can you say about the solubility of aldehydes ketones?
They're partially soluble in like water because they don't have hydrogen bonding, so they won't completely.
Yeah. So again, as long as you keep the hydrophobic part, like the hydrocarbon part, to a minimum. So smaller aldehydes and ketones. Smaller meaning something like formaldehyde, HCHO, formaldehyde, acetaldehyde, ethanol, CH3CHO, acetone. The smallest, like the beginning members, are all miscible in water. Miscible matlab they can mix in water. If not completely dissolved, they can easily mix. But as the mass increases, like as the number of carbon atoms increases, the solubility decreases. So as the hydrophobic part increases, the hydrophobia increases. So it won't be increases, the solubility decreases. That's it. And finally, like appearance, smell, taste, sight, all of that. You guys have seen or interacted with formaldehyde. Can anyone tell me where and how?
No, ma'am, I don't remember.
No, I know Ansh has. And I have an assumption, Mitali, Titi, you guys also must have.
No, but I'm not conscious about it. Like, how would I know that I will interacted with formaldehyde.
Ansh, you were saying something?
I have.
You have? Achha, you're asking, you have.
If I know Ridhima ma'am, I think you might have. I don't know if it was your batch or the batch after yours. Okay, you guys, abhi last 2 years to we were in lockdown, but uske pehle you guys have been to biology labs.
Yes, ma'am.
What did you do in biology labs?
Look
I
at
don't think
specimens.
I have.
Yeah, osmosis. Did a lot of random experiments.
Okay. Experiments, TK. Have you guys seen specimens in the biology lab?
Yes,
How are the specimens stored? Like, what are they like?
in a solution.
Yeah, what is that solution like? Have you
It's
melted?
clear. It's clear, and it does not. I mean, it's used as a preservative. So
Yes. Do you have any smell associated with biology labs in general?
no, ma'am. They're the most clean smelling labs in my opinion.
Oh, okay. So you haven't like gone close and interacted with the stored specimens and all that then.
Yeah, or it's been a very long time since we have. But
Okay.
ma'am, the stored specimens are also like sealed from top and bottom.
They are
So it's
sealed,
impossible
but
to smell and
So-
then get to know.
yeah, the solution in which those specimens are stored, like the thing that acts as a preservative, that is formaldehyde.
Ma'am, I've never been to a biolab.
No?
Never in my life.
Diversity chapter mein Ridhima ma'am didn't get like
Nahi, ma'am.
and all.
Nahi,
I
ma'am.
think you missed out by a year.
Ma'am, it must be Ansh Rupesh from Powai.
नहीं नहीं तुम like पोदार का batch ही था, but I think it was 1 year junior. Yeah, Rishit and all these guys. I
Okay.
think yeah, she got access to a lab and she seen that. So the specimens that are stored, that solution is basically formaldehyde. It is an extremely pungent smelling thing. It is toxic. It's you can't bear the smell. There's a reason specimens, corpses, like they look like that with hardened skin and all. It's not good. It's very toxic to living humans. So yeah, that's the main like place where you guys would find formaldehyde, like unless you went into chemistry later on. So it is used in storing living tissue. So even in like mummification process and all, formaldehyde is what is used. So it's a living tissue preservative. Don't use it for preserving food though. That's not what it's for. Okay. So you have like sharp, pungent odors. That's how it's described. But yeah, it's got a very typical characteristic smell. At least in my time, we'd associate biology lab ka smell with this. Like each lab had a different smell. Physics didn't really have any smell. Chemistry, it was a different kind of like chemical smell. You had the acids and the salts and all that. Bio was especially like pungent because of these specimens. So, what else do we have? The higher, so the small like formaldehyde is like that, but the higher aldehydes and ketones, nail polish remover, you must have seen, the smell is not very pungent. It's like more bearable at least. So the higher one.
And it's terrible, the smell. How do you think it's bearable?
You don't like nail polish remover ka smell?
I don't like nail polish or its smell. It's terrible.
Okay, then formaldehyde, you will not.
I love the smell
You will
of both
not
of those.
bear that. It is worse than nail polish remover. So imagine.
Oh my god.
So the higher aldehydes and ketones are more bearable. They're more fragrant compared to the lower ones. Ketones are more fragrant. Yeah. So that's, we talked about appearance, clear solutions, gas versus liquid and all that. We talked about the solubility. We talked about the smell, taste. Yeah. So these are the physical properties. Now coming to the chemical properties. So chemical properties may you guys have 3 or 4 main reactions. Let me check what all you have. So you have nucleophilic addition, reduction, oxidation, alpha hydrogen, and a couple of other random ones. Okay, 4 major ones. So remember when we were discussing the structure, this oxygen is highly electronegative. So this becomes delta negative. There's a slight positive charge to it. So this defines a major portion of the reactions of this thing. And consequences of this being positive tries to pull the electrons from the neighboring carbons. So most of the properties, so nucleophilic addition is directly related to it. So the nucleophile is added to the carbon. So that's nucleophilic addition. Oxidation reduction is like normal, like this you guys are aware of. Isko oxidize karne pe they turn into acids. And reduce karne pe go back to alcohols. Is normal. And you have alpha hydrogen ke reactions. So the alpha hydrogen is basically यहाँ पे अगर neighboring carbon है, then the hydrogen attached to this particular carbon. Now, because of this I effect, inductive effect, where it pulls on these electrons, this hydrogen becomes special. There's a slight acidic characteristic to it. So the reactions related to that. Okay. So you can see, like, other than oxidation reaction, other characteristic reactions are mainly directly related to the polarity of this bond. That's like a, so if you, even if you're at a loss key, okay, exam mein reaction aaya, so if I have an aldehyde, I have a ketone, how do I proceed from here? Start from here. Like think of what you can do. Can you do an addition reaction across this? So that'll start from here. It'll help you figure out, like predict the products. So I'll discuss the mechanism of nucleophilic addition. That's the first reaction. And then just like how you had electrophilic substitution with benzene and then like 5 different cases of it, that way we'll discuss the mechanism first and then 5 different cases of it. Agar nucleophile ye hua to kya hoga? If this is the nucleophile, then what do you get? Stuff like that. Okay. Nucleophilic addition. So addition reaction you guys have already done for alkenes. Alkenes ke case mein same thing, you have a double bond, just that you have carbon on both sides. Then depending on if you're adding HCl, to ek side H, ek side Cl. If you're adding H2O, then ek side H, ek side OH. So that way you predicted the addition, right? In the case of aldehydes or ketones, it becomes easier because then you don't have to worry about Markovnikov, anti-Markovnikov and all of that. C hai, O hai. C pe always delta positive, O pe always delta negative. So the positive part of the reagent will always go to the oxygen and the nucleophile will always go to the carbon. So that way it is very, very straightforward. Okay. So let's get into the detail. So suppose you have a nucleophile. What is the characteristic of a nucleophile?
It is it has a negative charge.
Has a negative charge. Yeah.
Yes, it's nucleus CK.
Correct. Nucleophilic liking matlab it likes positive charge. So it itself has negative charge to be attracted to positive. So you get a nucleophile and then either aldehyde or ketone. This is the reactive center you have, C double bond O. As I said, यहाँ पे delta negative है, यहाँ पे delta positive. Sorry, delta positive and delta negative over here. So because oxygen is electronegative, this attracts the double bonded electrons. So यहाँ पे this has a lack of electrons. So the nucleophile goes and attacks this carbon. So the intermediate that's formed will basically look like this. You have carbon. These two will remain as it is. Then you have the nucleophile that formed a new bond with it, with the carbon. And then you have oxygen with a negative charge because it's pulled on this double bond by electrons. Okay. So the hybridization, यहाँ पे sp2 जो था 3 became 4. So the hybridization changes to sp3. And this on electrolysis, like अगर nucleophile है मतलब इसका positive counterpart भी होगा, right? Like if I'm taking HCl, Cl is the nucleophile, वहाँ पे H plus P है. So that gets added to oxygen. So you end up getting OH. Okay. So this is the slow step. This is the deciding factor of the reaction. If this one is stable, if you push this reaction to form this, then this is the fast step. Matlab reaction khatam ho gaya, then consider it done. So this is the rate determining step. Forming like this conversion of sp2 to sp3 is the main part of the reaction. So this particular intermediate is called, it's Alkoxide Intermediate, and sp3 hai, isliye this is tetrahedral alkoxy intermediate. Okay. So essentially, if you don't have to worry about the mechanism, the addition is across CO. So from your reagent, if you can identify what will get a positive charge, what will get a negative charge, then the negative charge is always added to the carbon and oxygen will always take the positive charge thing. Usually it's hydrogen only, like HCl, H2O, H, CH3, COH, like whatever you take. It's always hydrogen. So this is what you end up having. So if we have to compare the reactivity, so reactivity will depend on how strong is this polarity and how easily is this particular thing forming. So between aldehydes and ketones, which one will be more reactive?
Aldehydes.
And why?
Ma'am, because aldehydes may there's an oxygen, there is a hydrogen atom which is attached to the carbon, so it can easily let go of that hydrogen atom and form another bond.
But why will it let go? Like these two bonds are intact. यहाँ पे जो है, they're preserved here. Hydrogen हो या कुछ और भी हो, like that it's not.
So then again,
heading.
so it'll depend on the polarizability of the ketones. Or I thought ketones were more
reactive here, right? But the reasoning is that one is sp2 is being converted to sp3. So aldehydes may one of this is hydrogen, ketones may both of these is like alkyl groups. So steric hindrance is a factor. So ketones has a lot of baggage. Pura structure badalna hai, to it's going to be slower than in the case of aldehydes. Because hydrogen hai, it can alter the shape structure quite easily. Another factor is the plus I effect of the R groups. So remember, I also told you it depends on the polarization, like the polarity of this bond. So यहाँ पे positive है. If I take ketone, so aldehyde के case में I have C double bond O H R. कीटोन के केस में C double bond O, R and R dash. So both will have positive charge on the carbon. The greater is the positive charge, the more easily it will attract the negative charge. Ketones में क्या हो रहा है ना? Both the carbon groups it attached to, abhi R is electron donating or electron withdrawing?
Electron donated.
So it is like both the groups are donating electrons from both sides on this carbon.
So it decreases the polarizability of the ketone
Yes.
carbon.
Yes. Aldehydes mein that's happening only from one side. So if you compare the positive charge on this carbon versus this carbon, यहाँ पे there's more of a, like this bond is more polar. यहाँ पे greater positive charge and greater negative charge है compared to ketone. So because that is due to the plus I effect of the R groups. So because of these two reasons, aldehydes end up being more reactive compared to ketones. Okay. So now, like these are the basics of nucleophilic addition. Whatever nucleophile you take, this is what is always going to happen. So there's addition across the double bond. The positive side will be added to oxygen, negative side to carbon. sp2 will change into sp3. You'll get a tetrahedral all single bonded product. So this is the reactivity K tendencies. Once you're done noting this down, we'll take specific cases. We'll take different reagents. So identify what is the nucleophile there and then predict kya products form hoga. And depending on the product, like agar yahan pe bahut sara like enol tha pehle, that got converted to ketone. So that way, depending on what products we get here, thoda additional notes rahenge for each one. Okay, give me an indication when you're done, okay?
Just a second, almost done. Yes, ma'am.
Okay. So Ansh and Riti are done. Mitali, Shantanu, let me know.
Yes, ma'am.
Okay,
Yes, ma'am, done, ma'am.
cool. So the first one, first nucleophile we look at is HCN. Hydrogen cyanide, it's a nitrile. So whether it's aldehyde or ketone, focus on C double bond O. This is where the addition will happen. Adding HCN. Okay, so first thing is, what is the intermediate that will be formed? So intermediate ke liye, these two will remain the same. This will become O minus. Nucleophile kya hai? What will be added to carbon here?
CN.
CN, yes. So HCN basically splits into H plus.
H plus CN minus.
Okay. So this is your intermediate, and बाकी यहाँ पे H plus जो है, that will get added to form this your final product. OH and CN. So when you have CN and OH attached to the same carbon atom, so this is called a cyanohydrin. Okay, this is the name of the product. That's it. As straightforward as this. You just needed to identify the correct nucleophile and it's added across C and O. So this particular reaction, if you want to make it faster, it can be catalyzed by using a base. and base matlab basically use OH minus for that, and we don't have to worry about OH minus being added instead of CN minus, because in general CN minus is a stronger nucleophile than OH minus. So OH minus will not interfere with the reaction, it'll just make it faster. Okay, so this is one example. The second one, sodium sulfide, NaHSO3.
So, ma'am, you're also Na plus and HSO3 minus, right?
This is slightly different. Ionic case may, like if it was ion, yes, HSO3 minus Na plus, but we've done like electrophilic substitution and all also with this. So sulfide ka structure is basically S is central, you have double bond O. Then you have sulfate में दो double bonds हो रहते हैं. In this case, you have OH here and then ONA over here. So this is the structure for this. So Na plus will get added over here and OSO2H will get added over to the carbon. SO2H, ONA. So in this kind of a case, there's going to be something called a proton transfer. So this is going to rearrange itself to form this product.
Ma'am, whether we write OSO2Na or SO3Na, it's the same thing, right? Makes no difference.
Makes no difference. I wrote it like this because then there is some clarity ki structure kya hai. Like important to note that this bond is not formed directly with sulfur. It is formed at oxygen. Like yahan pe break hoke, this is the one that connects with the carbon atom here.
Yes, ma'am, got it.
So even in the case of like sulfonic acids, like sulfonation and everything, the bond is always at oxygen.
Okay.
Yahan pe any extra this thing? So reactivity wise, so for aldehydes, the equilibrium is pushed. So equilibrium goes towards the right. And for ketones, the equilibrium is pushed towards the left. So ketones don't favor this reaction. Equilibrium goes on this side, and that is because of steric hindrance. So this whole thing is also like pretty bulky, and you have like alkyl groups on both sides. So you have like proper steric hindrance in the case of ketones. So the equilibrium goes to the left. So a speciality about this particular reaction, like why do we need to know about sulfonation, is when this product, so COHOSO2Na, so when this particular product is treated with a mineral acid or an alkali, either in acidic condition or in basic condition, this gets reduced to C double bond, like reduced next. So this gets converted into C double bond O. You get this back again, like the reaction is reversed. So this method is used in the purification of aldehydes and ketones.
So basically the final product that we obtain from the nucleophilic addition of NaHSO3, we treat that final product with a dilute mineral acid or an alkali, and that's for purification, right? For
Yeah.
aldehyde and
So you get your reactant back. So you basically you prepare this, filter it out so that you isolate only this particular compound, whatever has reacted, and then you reverse the reaction by treating it with this acid or alkali, and you get your reactant back. So that's why you use it in purification of aldehydes and ketones. Okay. Then we have addition of Grignard reagent and alcohols and ammonia derivatives. Okay. We'll do one thing. We'll take the remaining ones in the next class during the week. Mostly we'll resume on Thursday or Friday itself, so we can get this done this week.
Okay, ma'am.
Okay.